Hi, I'm Zander.
And I'm Thomas. This is our implementation of Euchre for the ECE 353 design project.
So Euchre is a trick-based game played with two teams of 2 players each on a reduced deck of 24 cards. So as you can see, each player gets 5 cards, and then the remaining 4 go in the middle. And this is the flop card. So then the first stage of the game is we go around the circle, and if you want to make this the best suit for winning tricks, you would go ahead and call that. And then the goal of the game is to win the most tricks, ace high. If you win at least 3 tricks in the hand, you get a point. And then if you want more in-depth rules on how picking the trump suit works and the exact hierarchy in that event, go ahead and look at the README. When we start up the game, the first thing you'll see is we slide the cards onto the screen. If you remember from homework 3, you can't draw images that overlap the edge, so we made a specialized function that handles that for us so it doesn't mess up the image. Next thing is the cards themselves. Our deck has 24 cards, and if we had 1 image per card, that would be a lot. We didn't want to take up that much flash memory and linker space, so we have a function that overlaps the suit image, the number image, and the outline onto a new image array, which is stored in the heap. So instead of 24 card images, we have 12 component images that we mix and match to build our deck. Another place we use heap memory is for the card flip that you saw, as it's changing the image for each frame of that animation, and we don't want to have to recomposite all the images constantly while it's running, so instead we make a copy and mess with that to do the card flip while the original is unchanged. You can see here there are 2 teams, red and blue, with the player being farthest left, so you're a member of the blue team. When you start a new game, you're the dealer, so the player next to you began deciding if they want to call trump or not, and as you saw, it rotates all the way around the circle, and it looks like none of them wanted this, so I'll go ahead and call it just for example. So you'd hit this button to call it, this button to pass, so I'll go ahead and call it, and then since I was a dealer, I get to exchange one of my cards for the flop card, so I'm going to click 9. 9's really low, so I don't really want it. Anyway. Then once again the player next to me starts by playing a card, so they're signified with yellow, and everyone else needs to follow that suit, and the highest card will take the trick. So as you can see, I can only play one of my spades. They already played the ace, so I might as well play this, not waste my king. And there we go. The rules for highest card are confusing at first, but intuitive with experience. Any card not following suit is worthless unless it's trump suit, and in trump suit, jack is highest, and same color jack is second highest. If you want an in-depth overview of rules, look in the README. These LEDs light up to signify the current trick win count, so we won a trick, so we have 1 LED lit up. And then our team is on the left, the enemy team is on the right, and there you go. If my partner and I collectively win at least 3 tricks in the hand, we get points. First to 10 points wins.
The capacitive touchscreen will be used for navigation. Aside from starting a game, the main menu has landing spots for user settings, which changes the system LED behavior and color, as well as a resettable game statistic. Both the high score and system LED configuration are saved to EEPROM, a form of non-volatile memory. The left and the right IO expander push buttons call or pass the trump suit respectively. With regards to overall gameplay, the up and down push buttons quit the game without saving. All push buttons are interrupt based and debounced before the user process can read their status. A USB to UART connection provides serial input and output to an external device. Here, pressing the spacebar pauses and resumes the game. The joystick, which is sampled via 10 millisecond timer interrupts, not only allows you to highlight the selection of your card, but also select the card itself. Opponent tricks won for a round are shown starting from the top IO expander LED and progresses downward, while the player's set transitions upward from the bottom LED. Unless otherwise noted, all timers are interrupt-based and 32-bit. The SysTick timer sets a flag for the user to update the IO expander LEDs. Now the 5 general-purpose timers. Timer 1 controls the blinking or breathing of the system LED, set to priority 1 so as not to delay triggering of the ADC reads as well as the setting of the game logic flag. Timer 2, which is a polling timer, adds delay in between the capacitive touchscreen readings for the menu. Timer 3 sets the flag to advance game logic. Timer 4, which is a 16-bit countdown timer for prescaler of 10, triggers the ADC sample sequencer, specifically sample sequencer MUX2, to begin reading joystick position. Finally, timer 5 ensures a 150-second countdown delay in between debouncing state transitions of the push buttons. It's enabled by the GPIF interrupt handler and sets a flag when debouncing is complete.